everyone, so today we are doing an exploration of tide pools at beautiful Giant Stairs, which is down in Harpswell, Maine. It's about a half-an-hour drive from campus. And what we're going to be looking at is tide pools and the Rocky Intertidal today. So let's start with the definition. A tide pool is a pool of water left behind when the tide recedes. So we can have tide pools occurring on any substrata, and here we're going to be looking at Rocky Intertidal tide pools, but you can have them in mud, you can have them in sand, you can have them in the salt marshes. Anywhere that the tide, when it recedes, leaves a pool of water, that by definition is a tide pool. So we're going to be looking at tidal pools along a transect line that we've laid out here at Giant Stairs, along a tidal gradient from high in the intertidal to low in the intertidal. So remember that the intertidal has a high of about 10 feet here, and a low mean water is at 0. And so we're looking at the tidal height gradient here and the tide pools. So what we're going to be measuring is water chemistry. We're going to be looking at dissolved oxygen, temperature, salinity, and pH. And we're going to be looking at those four water chemistry variables as they relate to the organisms that live within the tide pool along the tidal height gradient. So there's a lot to take in here. And we're going to show you the series of tide pools. High in the intertidal, you can see that there's a tide pool up there that's green, and that's dominated by predominantly one species. And then as we move down the intertidal, we have another tide pool here, which has some organisms living on the bottom and some algae that's floating in the water. The algae that's floating in the water is, of course, adding oxygen to the water. As we move down, I'm going to see if I can walk a little. We have two more tide pools. We have one here that's long and skinny. That's sort of in the mid of the tidal range, and that has a variety of organisms that's different from the upper two tide pools. Lots of algae, lots of snails, Littorina, Littorea, some new organisms that you're going to meet today. And then further out, we have another tide pool that's even closer to the open ocean. So as the tide recedes, each of these tide pools gets disconnected from the ocean at different times along the tidal cycle. And so immersion time spent disconnected from the ocean, is really important when we're considering the water chemistry and how all of that affects the organisms living in the water and all the organisms, how they affect the water chemistry. Those are the things we're going to be looking at today. So the highest tide pool is dominated by one species. This tide pool is amazing in that it does not get flushed by the tide every day. It gets flushed by the tide only on the highest highs, which means probably once every few weeks. It's going to get fresh ocean water brought into it. And so otherwise, the organisms that live up there experience extreme stresses. They have extreme of temperature, they have extreme, so they experience highs and lows in the temperature, and salinity can change. Like on a day like today, it's a beautiful sunny day. There's a lot of evaporation happening. Salinity is on the rise. If we were to come out here during a rainstorm, salinity would decrease over time. So the organisms that live in the highest tide pools experience the greatest stress. And remember, these are marine-derived organisms that are living in these tide pools. They would really rather be in the deep ocean, but they're pushed up here and they're at their physiological and biological limits. We're in the tide pool. And then as we go down in tidal height, we are closer and closer to the ocean, and we have less time separated from the ocean, so the organisms that live there experience less fluctuation in all of the water chemistry variables. And that's important to think about when you're considering who's living there, how are they living there, how are they making their living. What you'll see is the lowest tide pool has what we call some subtidal animals in it, and that's because if they, in their plankton phase, if they are brought up into the tide pool and they settle, they can live there because they stay submerged all the time, as long as they're not at their physiological or limit at the water chemistry, as the water chemistry changes. So that's kind of the gist of what we're going to look at, is the tidal height gradient, the organisms who live in the tide pools, how they act to change the water chemistry, and how the water chemistry affects the organisms who are living in the tide pools.